Hello, good evening, everyone. So, in today's session, we are going to discuss the results of the cufflinks. So, do you have any problem till the mapping part? So, everyone has run the cufflinks command in their system.
Yes, I have.
Okay. So, can anyone tell me what the cufflinks tool it is giving? Or what does the cufflinks tool means? Anything you have idea about this cufflinks?
Ma'am, I think
Ma'am, it will
it
give
can
the
actually.
count of reads. Okay, Imran, what it
Yes,
is?
ma'am. Actually, I think it's mapping the reads and transcribe them into the transcript like expression.
Okay, Jezreel, Jezreel, what is cufflinks tool? Okay, fine. So cufflinks is an essential tool for studying the gene expression, alternatively splicing and gene regulation. So it is providing you the valuable insight into the transcriptome, and it assembled the fragmented RNA seq reads into the continuous transcript. So that means whenever our gene got expressed, transcript will express. So here, whatever the result will get after the cufflinks, that would be the transcript files, right? So in those files, we'll get the count of each sample or reads. So here you can see in the cufflinks output also, you're getting the transcript file, right? So we can see multiple reads are mapping, and also we might get the bias nest in our data. So if there is an error or biasness in our data, we need to remove manually, right? But manually, if we do, so still there are some chances we might get the error. So that bias nest or the error, it is sorted with the help of the cufflinks. So cufflinks, what it do, it normalize our data. So understood what is the normalization? So it is removing basically the bias nest from our data. So there are two type of factors. Do you have any idea what type of variation it is? Technical variation and biological variation. So let's understand what is this technical variation. So in this technical variation, first it is having what the sequencing depth. That means the number of reads sequence can affect the sensitivity of the cufflinks in detecting the low abundance transcript. So that means higher sequencing depth generally leads to better detection. So let's understand with the help of the diagram. So for example, this is my control sample and this is my treated. For this control sample, like I'm having 30x depth, and for the treated, I'm having 50x depth. So what is this 50x depth and 30x depth? Any idea, guys?
Reads, ma'am, number of these are number of reads which are common and aligned.
Yeah, so 50x depth here means 50 reads here. And here it is 30 reads. From this diagram here, like we can say there are more number of reads here in the treated sample. And from looking to like the reads number, we can say in the treated sample, gene expression is high, right? But that is not true because you can see there is a variation of the depth here. In the treated, it is having the 50x depth, and in the control, it is having 30x depth. So there might have like you have chance of the getting the error in your data. So that error or the biasness due to the depth, it is normalizing with the help of the cufflinks. And also, if you have the gene length, for example, this is a gene here, and this is a B gene. Again, the length of A gene is what? 100 base pair. And for this B gene, it is having 1000 base pair. So again, you can see in the B gene, 900 bases are missing here, right? And more number of genes are going to map here in the B gene, right? Because the length of the B gene is greater. But again, we cannot say like if the B gene is higher, okay, or it is having the high length, we cannot say the gene is expressing more in the B gene. So this error due to the gene length or the depth, it is going to resolve with the help of the cufflinks tool, guys. Next, that is what sequencing error rate. So error in the sequencing process can also introduce the noise into the data, which is leading to incorrect transcript assembly. So you should make sure whenever like you are performing the sequencing in the wet lab, so the data should be clean. Otherwise you might get the error. Next is the read mapping quality. The quality of the read alignment to the reference genome can also influence the accuracy of the transcript, assembly, and the quantification. So any doubt in the technical variation, guys? Understood?
Yes,
Next,
ma'am.
in the biological variation, there is a RNA degradation. So that means RNA degradation can also affect the representation of the transcript in the RNA-seq data, which may also lead to the biasness expression. Next is the sample heterogeneity. That means biological variation within a sample can make it difficult to accurately quantify the transcript expression level. So that also it is going to remove with the help of cufflinks. Is it clear? The
Yes, ma'am.
technical variation. So see this technical and the biological variation or any biasness, whenever like you are downloading the huge data, we cannot remove, because there are some chances you might get the error. So that errors is going to removed with the help of cufflinks, and the cufflinks will give you what the FPKM values. So FPKM is what the normalized count of the reads here. Okay. So FPKM stand for, any idea what is this FPKM?
Fragments per
What? Fragment.
Fragment per kilo megabyte megabase.
So whenever you are analyzing the data, you will see tomorrow in the session, you will get only the FPKM value. So that is what the, after the normalization of the data, you will get the reads, okay, in the cufflinks output. And that you will see further in the analysis part tomorrow. But what I mean to say, the gene expression, it is given with the help of FPKM values. And FPKM stand for fragment per kilobase per million mapped fragment. Clear? So this FPKM is a unit to measure the relative abundance of the transcript in the RNA-seq. It accounts for both the number of reads mapping to a transcript and the transcript length, and it is providing a more accurate measure of expression level compared to simple read count. So for each transcript, cufflink is calculating what the FPKM using the following formula. So if you want to know how it is calculating the FPKM value, so I will tell you what is the formula. You can mute yourself, guys.
No.
10 to raise to power 9 multiplying with the C. So I will tell you what is C here. Then divided by N into L. So let's understand what is the C, N and L. So any idea what is the C? Have you ever heard about this? So C is the number of reads mapped to the transcript. Next, N is the total number of mapped reads in sample. whereas this L stand for the length of transcript in kilobase. So by this formula, it is calculating the gene expression. Clear?
Yes, ma'am.
Now let's understand what is the cufflinks output it is giving you. So just open the cufflinks control one output in your system. And then you will get these 4 files, right? So any idea what is a skipped.ptf file it is containing? Task. Just mute yourself, guys. What is a skipped.gtf file here?
It's an express gene in the control sample.
What, Jezreel?
It's express gene
No, no, no,
in
no.
the control sample.
That's not the skipped file. Skipped file is not the transcript. So that will be only in the transcript file. So the skipped.gtf file is what?
Ma'am, they
It
are
is
the exons.
exons.
Unlike the exons which are not included in the transcript. Ma'am, like which are in
Yeah.
XT.
So skip.gtf, it identify the region of transcript that were not covered by the reads. Okay. Next, you will see the gene.fpkm file. This one. So this gene fpkm file, it will just again provide you what the fpkm value for each gene, which will include the gene IDs, gene name, fpkm values. Again, all other files that you have the isoform transcript. Again, in the isoform also, it will have what the values, it is in the fpkm values here. Okay. But in the cufflinks output, the transcript.gtf file is the main file. So now you can see in this result, first location it is giving you for the chromosome, right? As it is a chromosome 16 here. Next, you can see the cufflinks output, like you have used the cufflinks tool, right? So that tool name it is giving you. Next, they are giving you the feature. You can see the transcript, exons here. Next, this is the location of the transcript, start and the end position they are giving you. Then next you can see here minus. Can you see? What is this minus plus here?
Ma'am, the reverse strand
Correct. Correct,
and
Divansh.
forward strand.
Minus is for the reverse strand and plus is for the forward strand. So you don't worry with this dot. So this is nothing. The gene ID they are giving you, then the transcript ID they are giving you, then you can see the FPKM values that we have discussed just before this cufflink output. So they have calculated the FPKM. So this is the normalized count of the reads here, guys. Next, what is this conflow and confi? Have you ever heard or any idea about this conflow?
No.
So
Confidence
conflow,
level.
like, tell me.
Confidence level.
Yeah, right, Shubham. So this stand for fragment per kilobase of transcript per million mapped reads, confidence interval lower bound. So it represents the lower limit of the range within which the true FPKM value for a particular transcript is expected to fall within a certain degree of confidence. Clear what is it is? Imran, what it is?
Sorry, ma'am, I get lost.
Okay, so it is representing the lower limit. Within the true FPKM values. Next, what is the conf high? Shubham, what it is?
Should be higher limit.
Yeah. So it stands for fragment per kilo base of transcript per million mapped reads, and it is giving you the confidence interval higher limit. So it will represent what the upper limit of the range within which the true FPKM value should fall. Clear? So this conflow is nothing, just the lower limit, whereas this conf high is what? The upper limit. Clear? Any doubt? Next, you can see the cove word here. So cove means what it refers to the coverage of the particular region or the feature in the reference sequence. So it indicate the average number of a time nucleotide that has been sequenced. So here in the coverage, we can say if you have high coverage, so it is suggesting higher sequencing depth, which is leading to greater confidence in the observed expression level. Clear what is this coverage?
Yes, ma'am.
Next is the So it refers to the fractional abundance of a transcript. So a higher fractional abundance of the transcript value will indicate a greater proportion of the total RNA in the sample, which is composed of the transcript. Clear what this transcript file is containing? All this data, it is clear? Shall we proceed further?
Ma'am, high frac value means higher RNA content.
Who is this?
Ma'am,
Narinder?
Divyansh. Ma'am,
Divyansh?
Divyansh.
What Divyansh?
Ma'am, like higher frac value means higher value of RNA content in the
Yes,
transcript.
yes. So it will have the greater proportion of the total RNA in that sample. Okay.
Okay. Yes, ma'am.
Now, next. So you can see like in the cufflinks output, you are getting total 4 transcript files. So this is for the cufflinks control 1. Now again, if you open this control 2, you will get the transcript file. So total, how many transcript files you are getting? Shubham, how many total transcript files we are getting here in the cufflinks? Divyansh? Priyadarshini? What? Yes, correct. 4 we are getting, right? So as we have discussed in the pipeline also, once we have the 4 transcript file, so whenever we want to do the differential gene expression, we want to merge these transcript files, right? With the help of cuffmerge tool. Got it? Now let's understand what is this cuffmerge tool. So in the cuffmerge tool, you have to call the cuffmerge tool. Then -o is your output name. Here I'm giving. Then in the -p, this is the threads I'm providing. And in the -g, I'm giving the GTF file here. Next -s, you can see you have created what the index genome. So index genome you have to provide here in the -s. And assembly.txt file, it will create, like it will have all the transcript file. So in the merging tool, we have to create first, that is the assembly.txt. So what you have to do, just open the cufflinks control 1. Then from up, just open the WSL. Then do it ls here. Then pwd. So you have to copy the path of the transcript file in the notepad. Just open the new, then put / here. So I want to have access for the transcript file. So you can see it is written in the transcript.gtf. Just copy that and put here in this. So likewise, you have to do for the control 2 also, treated 1, treated 2. Can you do?
Can you repeat, ma'am? Please repeat. In WSL, I have entered ls and pwd after pwd.
Yeah, so just run this command ls pwd. Done, Narendra?
Yes, ma'am, done, ma'am. After that.
Now everyone should copy this white color path of the cufflinks, this one. Okay. Then just paste in the new sheet in the notepad. Okay. Then you have to put / here. Then put transcript.gtf. Done.
Yes, ma'am.
So likewise, you have to just rename the files here. So I've written control 2. And here I will just write treated 1. And here I will write treated 2. So it's up to you if you want to go inside, like again in the control 2 and you have to copy the path, it's up to you. Otherwise you can rename like this also. But just make sure this cufflink output is in the raw data. Done till here, everyone?
No, ma'am, please repeat.
Ma'am, sorry for disturbing.
Yeah.
Ma'am, we should copy our username and all desktop username. For me, it's not coming there.
What, Narinder?
We should copy like.
No. What you do, just go inside the raw data.
Yes, ma'am.
Right? Open that. Then go inside the cufflinks control 2. Again, open the WSL here.
Inside cufflinks control 1, right?
Yeah. So every file you have to go inside. In the control 2 also treated one, so that you will come to know from where the links I have taken.
Yes.
Yeah. So everyone should do along with me, because I am not going to conduct any more session with this cuff merge and the cuff diff, guys. So in the today's session, we are going to complete the pipeline, and from the tomorrow onwards, the analysis part will be done.
Ma'am,
Yeah, Priyadarshini.
ma'am, after running the command, I'm getting no such file or directory.
Just share your screen.
Yeah.
No. What you're doing, Priyadarshini?
Yeah,
I just told you to just write ls and pwd. That's it. Just copy the path of the cufflinks control one up
this
there.
one.
Yeah, copy that. Go to notepad. I can't see your screen, Priyadarshini. Did you open the notepad?
Yeah, ma'am.
Okay. Just paste that. Pasted.
Yeah,
Now, can you see, like, after running the ls command, there is a transcript.gtf, right?
yeah,
Just copy that and go back to the notepad and put slash there, then type transcript.gtf.
yeah.
Done.
Done, ma'am.
But I can't see your file. Where it is? The notepad.
1 minute, ma'am.
Yeah.
Ma'am, we should do for all four, ma'am. Control 1, control 2.
Yes. For each and every file.
We should
Yeah.
run the command.
Yes. You have to put all the path of the transcript file here in the notepad, guys. Okay, like she is doing, you can see. Now, Priyadarshini, again go back to control 2 folder. Open the WSL. Yeah, Monab, I will fix it. But before that, you can run the cufflinks in your system.
Ma'am, every time we have to open the WSL, or we can just change, that means control 2, we have to just edit that. If treated 1 and treated 2, we can do like that also.
Yes, you can also do like that if that cufflinks output is in the same folder, ma'am. Okay.
Okay.
Otherwise, it won't take the path of that transcript.
Okay.
Yeah. Yes, so open the WSL here, Priyadarshini. Yeah, now just write here PWD again. Enter. LS. No.
Yeah,
Just write here CD. Space. Go inside the cufflinks, control 2. Copy that. Enter. ls pwd. Copy the path of this, Control 2. And then paste there.
Yes, ma'am.
Now again, just after like Control 2, put slash there, and after slash put the transcript dot in the notepad. Okay.
Here, ma'am.
No, not here, Baba. It's in the
Okay. I done, ma'am, done.
done. Just open that notepad now. Yeah, what you can do now, just copy the path of this Control 2, paste it below 2 times. Again, one more. Yeah, now instead of Control 2 here, just type here treated. So type here capital T, because otherwise it won't take the treated to file, because you can see in the folder it is in the capital letter. Okay, just type here treated 1. Now make it here treated 2.
Ma'am,
Yes.
ma'am, for me it's coming command not found, ma'am. In the result, for every step it is coming command not.
So did you perform this?
Yes, ma'am. Can I share, ma'am?
No, just wait. So I told you to just to paste the link of the transcript, that's it. Now what you have to do, just save this file inside the raw data. Okay. And you have to type here assembly.txt. So it should be in the .txt format, guys. Done?
Yes, ma'am.
Just save this. Now go inside the raw data. You can see the assembly.txt file here.
Yeah, found, ma'am.
Done. Now you have to run this command, the cuff merge.
In the same WSL, ma'am, or else we should open once again.
You should open where the assembly.txt file it is there. Okay.
Okay.
Ma'am, actually I have a minor problem.
Yeah, just wait.
Yes, ma'am.
So you can see the cuff merge is started. Narendra, share your screen.
Yes, ma'am. Ma'am, is it me
Yeah.
or Divyansh? Ma'am, it's me, ma'am, Divyansh.
Rabina, whose it is?
Ma'am, it's mine, Divyansh.
No. Who just text in the chat box? Please don't share the command, guys, in the chat. Because for each and every system, these commands are different. Okay. Divyansh?
Yes, ma'am. So, ma'am, I have these cufflinks. So, ma'am,
Yeah.
ma'am, I have like the transcript file for like 3 of
Mhm.
them. But ma'am, in control 2, ma'am, it's an empty folder.
What about the treated 1 and treated 2?
Ma'am, I have done it, ma'am. It has the transcript files.
Okay. Just try to run this cufflinks control. Maybe some error it is there in the command. Just check it once. Do you
Ma'am,
have
so
this?
ma'am, so
Just
वापस install कर लो.
wait. Can you see Divyansh? Go down. There is a sorted control.
Yes,
Where
ma'am,
it is
sorted
sorted
control.
control 2.
Ma'am, Sam, bam.
You can see the data it is not present, Divyansh. You have to run it again. It is containing 0 KB. Can you see? There is no data.
Yes, ma'am.
So how did you perform? So it was giving error while running the commands.
No, ma'am.
So somewhere in between you have like performed wrong step, because you can see 0 KB here for the files. So that means there is no data. That's the reason like it is not creating any transcript file. So what about others? The same problem you are
Ma'am,
having?
no, ma'am. My mother have like the transcript file.
No, Divyansh. Nahi, like it's fine for this, but you can see. Let me check in my file. Divyansh, you have to run it again. See, some error is there. It is not possible like it will have 0 KB, because in the raw data, while we were downloading the raw data, there are reads in the control and the treated sample. So you just delete the sorted, control, treated every file.
I'm only the sorted one.
No. Everything you should delete with the 0 KB. Yeah. And also control 2 BAM file, I can see there is 0 KB. Control 1 BAM file.
Yes, ma'am.
Done. Just
Yes,
wait.
ma'am.
So I guess mapping was not done carefully. So just try to run it mapping with the help of HISSA 2. Again do it. Okay.
Yes,
Khadija will see it later on, because you like in your system the Python it is not installed. That's why like the cuff merge is not opening. What about Amit?
Ma'am, hello,
Yeah.
Sumalita.
Yes, ma'am.
Ma'am, can I share my screen once?
Yeah. Imran, just wait. After this, like you can share your screen, okay? Yeah, what's the problem here? Khadija, Python 2 is not installed in your system. Sumalta, are you able to share your screen?
Please, are we running that command one by one? The transcript text file.
No, sir. Like you have to create one file with the name of assembly.txt.
I've done that already.
Yeah, you did it. So just wait. I will show you.
Okay.
again.
Okay.
Yeah, can you see my screen?
Yes.
General, yeah. So in the assembly.txt, you can see for the 4 transcript file, I have provided the link, right? Then you just save this assembly.txt in the raw data.
Okay.
Then after this, you can run this command. Do you have RNA-seq pipeline with you? This pipeline?
Yes, I have it.
Just
Yes.
go to number 6. There is a cuff merge. Do
Okay.
you have this GTF file in your system?
Yes.
Yeah,
Yes,
you
I
can
have it.
run this. Okay, so run this command inside this raw data where your assembly.txt file is there.
Okay.
Okay, yeah. Imran, you can share your screen meanwhile.
Okay, ma'am.
Yeah, Khadija, you have to install Python too.
Hello, ma'am. Can I share now?
Just wait, just wait.
Yeah.
Yeah. Imran, just go to the tools. Do you have cufflinks tool? Yeah.
Okay.
Open this cufflinks. No, not from here. Just open that. Yeah. Can you just open this cuff merge file below? Yeah. Priyadarshini, good. Yeah, Python 2 done. So, okay. Just open the terminal now. I can see you have written Python 2. Yeah. Cancel this. Now open the terminal. Yeah. Just write here Python. Enter. Okay. Control Z. Do like you have installed Python 3 version, Imran?
Yes, ma'am. I was trying to install Python 2, but I have tried. I mean, if I write here conda activate Python 2, then it changed the environment.
I know, but why like you have created the environment here in your system? I told you to not to download the Anaconda in the Windows system because it is not required. Already like in the Windows system, we are working on the WSL. So I told Anaconda for the Mac people. Yeah.
Yes, ma'am.
So,
Yeah.
okay, let's see. Just write a
Mhm.
sudo space apt-get install Python 2. Enter. Okay. Actually, we have to remove the Python 3 version, so long procedure. Imran, just wait after this session.
Oh, all right, ma'am. Okay.
Yeah. So meanwhile, whoever has run this cuff merge, they can perform the cuffdiff also. Now I will tell you what this cuffdiff is. So with the help of cuffdiffs, we are going to perform what the differential gene expression here. So I told you there are 2 type of plan, that is treated versus control, or maybe control versus treated. So it's up to you which plan you want to take.
Please,
Okay.
I'm having error. I'm having error in my listing.
Okay, you are still performing the cuff merge?
The cuff merge, yeah, but I'm having error. I don't know.
Okay, you can watch the recording. If you have still like problem in the cuff merge or maybe cuff diff, just let me know tomorrow. Okay.
Okay.
But
Okay.
meanwhile, you can see how we are running this cuff diff because for tomorrow, we need the Excel sheet because from the tomorrow, the analysis part will be started. Now, just call the cuff diff tool here. Again, in the -p, there is a thread I'm giving. And in the -o, I'm giving the cuff. Just mute yourself
Thank you very much, sir.
as well. In the -o, just give the cuff diff output name. And in -l is my plan here. So can anyone tell me which plan I have used in this pipeline? Shubham, which plan I've taken?
It's control versus treated.
Why, Priyadarshini?
Because control comes first.
No. So make sure whenever you are having it
Is
treated
treated
over.
versus control, no?
Yes, yes,
The
Narendra.
result is control, result L control.
So whenever you are having a plan that is the treated versus control, so make sure you have to put control first, then treated. Whereas when you are taking the control versus treated, it is just opposite to that. You just have to write treated, comma, control. So now it is very clear from this pipeline, we are going to use this plan, treated versus control. Okay. Now in the -u, so you have to provide the merge.gtf file. Okay. So from where the merge.gtf file I've given here, you just open the cuff merge output result. You can see the merge.gtf file. Priyadarshini, do you have this merge.gtf file?
Yes, ma'am.
So now from here, you need to open the terminal, that is the WSL. And just type here pwd ls. And you have to provide this path, okay, merge.gtf file. So just copy this.
Mom, should we rename that merge.gtf or else it is in text form?
Which?
That merged one, merged issue.
No. It is in the GTF format, na? So you don't need to convert anything. Keep it as merge.gtf. That's it. Copy this because we are just providing the path. So here it is the path of the merge.gtf. Clear? So now further you can see. Let me just explain this cuffdiff command, then we'll end and then we'll fix your problem. Okay. In -u, did you got this? Like, what is this? This is the path of merge.gtf here. Then as you can see, my plan is what the treated versus control. So first files I should provide for the control. So yeah, now you can see I'm giving the sorted control file. Why? Because in the sorted control files is what data? Any idea which data it is containing sorted control files?
BAM.
No. It's a BAM format, I know. But what type of data it is containing? Sorted.
Has the transcript data.
Correct, Priyadarshini. So sorted control 1.bam, then give the comma, then give your control files, then put a space, then give it for the treated 1 and treated 2. Now simply just copy this and run this command. Clear? Any doubt in the command, guys?
मैम
Yeah.
मैम आज WSL इंस्टॉल कराएंगे आप?
Who's this?
नवनीत.
Okay. Yeah, Navneet.
Ma'am, where we should run the final command? This command
In the raw data, no?
in the RAR.
Yeah. I don't know why you guys are getting confused from where to run. So just make sure, like whenever you are running any command, you have to see all these files are there or not in that folder. In that folder, if the all the files it is present, that means from there you can run the file, like the command. Shubham, you can see the recording. Yeah, good, Priyadarshini.
Ma'am, it is saying warning message.
Which warning?
Something update current version.
Like this, Narinder?
Yes, ma'am, but for me, this and all is not coming. Like inspecting maps and all, it's not coming. Only first one came and it stopped.
Just share your screen. So till here, till the cuffdiff, you have to perform, guys. Okay. Um. Just show me the command.
This is
You have to provide the merge.gtf now. After the cuff merge output, put slash here. Then type merged.gtf space and go back to the raw data. Just open the cuff merge output. Yeah, do you have? Yes, yes, yes. Okay, fine. Just go back to the command now. Now run it.
okay.
Done.
Yes, it's coming.
Ma'am,
Yes, Priyadarshini.
it's showing error.
In the command.
Yeah. Cannot open reference GTF file.
Yeah, just share your screen. You have to run this command in the raw data, not in the cuffmerge output. What you are doing, I don't know. Priyadarshini.
Okay, okay, ma'am. Okay.
You are running this in the cuffmerge output.
Okay. I should run in raw data.
Yeah. In the raw data.
Okay. Okay, ma'am.
Okay. Yeah. So everyone who has generated the cuffdiff output can leave the session, and we'll do the analysis part from tomorrow. Just make sure like you be present.
Ma'am,
Yeah, Narendra.
ma'am, it's Divyansh. Ma'am,
Yeah,
like I have edited the BAM files so now, ma'am, जो
Mhm.
अभी cufflinks बनी है मैम उनको भी delete करो.
Yeah, again run that.
Okay, ma'am. So ma'am, जो अभी cuff links बनी थी उनको भी delete करके
Yes,
वापस
yes.
करना है.
Everything you should delete and just try it again.
Okay, ma'am, वो अब बन रही है BAM files so ma'am पूछना था कि delete कर.
Okay, no problem.
Okay, ma'am. Thank you.
Ma'am,
Yes, Priyadarshini.
ma'am, once again I'm getting the same
Just share your screen.
error.
Meanwhile, who is having a problem in the cuff merge, they can download the any desk in their system.
Hello, ma'am.
Yeah.
Shall I wait for some more time?
Yeah, just wait. Just cancel this. Can you just do it in front of me, Priyadarshini?
Yeah, I'll close it.
Just open the cuff merge.